Hi, you four. Welcome to your computing flipped classroom for this week. Sorry, it's gone up a bit late, a few technical difficulties, but please have a look at them. This is going to help you. So for this computing flipped classroom, we're just going to have a look at the Knowledge Organiser, and then we're going to go and have a look through the key vocabulary that you're going to be using and what we're going to be hearing during this topic. So let's get started. I'm going to share the screen with you. Okay, so this is our Knowledge Organiser, and this is what we're going to be looking at. So I'm just going to zoom in a little bit so you can see what we're doing. So here we've got obviously your subject is computing. The unit is called we are game designers, but what you're going to be doing is really you're going to be making a robot that can move on the screen. So we're going to change that to we are robotic engineers. So these are your keywords, and we're going to have a look at them in a moment, but you can have a look down there. And what you can do before you look at the video later on, have a think. What do you think these keywords mean? What do you think they are? You know, so coding, debug, sprite, input, output, pattern, sequence, repetition, sensors, lights, and motors. What do you think them keywords mean? The software that we're going to use. So software means the program that you're going to use on the computer. And the program that we're going to be using is called Scratch. And you can use this online, and you can access this at home online as well. So when we do our flipped classroom, when I'm showing you new techniques to use with Scratch, we can actually have a look. You can actually have a look at the flipped classroom, and you can actually practice at home before coming to school. So software are programs that we're using, and we're going to be using Scratch. The hardware is what are we actually using Scratch on. So you're going to be using Scratch on the computers. So we've got a nice picture of the computers here. And we're also going to use something called InnoBots. Just one second. I call this a bit of hardware because it's an object that we can actually use. Okay, and the idea is this is not the first ones to use as well. We didn't use them last year, but these are kind of new, and they're sort of like little robots. And hopefully we can get to the stage where we're able to use these, and you can actually program stuff in on Scratch on here. So yeah, very exciting start to the year. So e-safety, as always, when we use computers or we use technology, we do have to be safe. And the things that make this safe and that you need to be aware of is that if you were to use Scratch online at home, you don't need to have an account for it. Therefore, you don't have to share any personal details, emails, anything like that. You can just use Scratch without using an account. If you wanted to share your work with other people around the world, you would have to get an account, but you would have to ask your parents' permission or whoever looks after first before you do that. But the great thing is that you don't need an account, so you don't need to share any information. You can use pictures off the internet and copy them onto Scratch as well if you want to. However, you do need to be aware that if you are doing that, you need to check that you're actually allowed to take that picture. Because sometimes, there's something called copyright, and if you take a picture that doesn't belong to you, you can get into a lot of trouble. And of course, when we get to use these bots, or if we get to use these bots, using the hardware, make sure you know how to use them safely. So for example, you're not going to be sticking things in places that you shouldn't be, because it is electrical, and you can get electrical fires, and you can get an electrical shock from it as well. Probably won't happen, but there's always that risk. So we have to, when we come to using these, we taught how to use these safely. So what are you going to understand when you do this topic? You can understand that we can actually put loads of different inputs into a robot. It's not just about movement, it's also about sensors, switches, lights, motors, and sometimes even speakers. You're going to know that robots work by preset codes made by humans. Okay, so this robot, this InBot, when we make it move, it's not going to do it just on its own. We're going to tell it what to do. Okay, so we're going to give it the rules to follow. You yourselves will be designing a prototype robot that you will design on paper first, and then transfer that onto Scratch. And then you're going to make that robot move and add an element to it, so it's a robotic feature. And that will all be done on the computers on Scratch. What will you become? You're going to become a robotic engineer, designing and programming your own robot. So very exciting. So this is the Knowledge Organiser. This will be put up onto Tapestry very soon. So you can have a look at it now. Now, the next thing we're going to look at is the keywords that you're going to be have over the next course of the few weeks. So let's get them up, shall we? So here are the key words. Start my slideshow. So coding. Coding is going to be the first keyword that we come across. And coding is when we is the process of giving a piece of software rules to follow. So for example, coding would be here if we were getting this robot to move forward 4 spaces, turn 90 degrees left. They are all codes that we put in. And the whole process of putting in these codes and rules is called coding. So this is the process of making your robot move and giving it rules. Debug, I like this word. Now, debug is a word that if we've got a problem in the computing world, we call it a bug. All right. So if my computer wasn't working properly, I would say, I think I've got a bug on my computer. The word debug means to get rid of that bug, to get rid of that error. So for example, you may want to make your robot move forward 10 paces, but it's only moving 5. Why is that? So you would have a look at your codes and you would say, oh, look, there's the problem, and fix it. That process of looking at your codes, fixing, and then testing it again to make sure it's correct is called debug. Okay, so that's called debugging, very important. You're going to hear this word debug throughout your computing lessons throughout the whole year. The next word is pattern. So when we put in patterns into Scratch, we can have things repeating, or we can have when something happens, when a certain thing happens, let's say our robot hits a wall, what's going to happen afterwards. And these are patterns that the robot will follow over the course of the coding process. So a pattern sometimes may be a recurring pattern where the same thing is happening, or the same thing happens every time, your robot hits a wall. What happens? It turns 90 degrees. That is your pattern that you're following for that process. Sequence, very similar to pattern, but this is a sequence of events that happen. So your coding that you're doing, walk forward 5 steps, turn left, move forward 5 steps, turn left. This is a sequence of codes that you're putting in. Input. Input is basically what it says. You put something in and it's the way it happens. So for example, when let's say I've got a microphone. A microphone is an input device because you speak into the microphone. So that amplifies your voice. When I'm typing on the computer, if I was typing in letters, the input is the keys on the keypad. If I move my mouse around the screen, okay, that you can see at the moment, I'm moving that using a mouse. A mouse is an input device. Okay, telling the computer to do something is an input. So when you tell your robot to do something, you're giving it an input. Then you have output, which is the opposite. So you've told the computer to do an input, it thinks about it, and then you see it. So for example, the camera on my screen at the moment is an input, and then the monitor that you see is an output. Okay, so the camera takes in the information, gives it to the computer, then the computer displays it onto the screen. So a screen, a monitor, is a source of an output. Okay, similar to music as well. If you've got speakers, speakers are outputs. We then have a sprite. So in Scratch, you're going to make a sprite, and a sprite is a term given to your sort of robot that you're going to make. So, or in any game that you see which moves along, things that move and things that you can give codes on the screen are called a sprite. Okay, so if you've played the old Mario or Sonic games, they're actually referred to as sprites. So that's their technical computing name. Sensor. A sensor is something that can detect an object, or it can detect a certain smell, it can detect light, it can detect heat. So you have different types of sensors for different things. So when you think about your robot, what kind of sensor do you want to have on your robot, and how's that going to work in your game? And not your game, your in your robot you design on scratch. For example, the Roomba vacuum cleaner has sensors on the front. When it comes near to a wall, it will stop because that sensor is telling it to stop. So what will your sensors be like on your robot? Repetition, that's when you just keep on repeating something time and time and time and time and time and time again. Now, lights, we all know what lights are. They're a source of light. You've got lights on the ceiling, you've got lamps, you have lights on cars and things like that. So lights project light. It is a type of input, it is a type of sensor that we can use. We have motors as well. So motors make things turn, and we can put sensors on motors. And that is all of our key words. So that's our key vocabulary computing lesson with our knowledge organizer on it. This video will be up on every single playlist, so you can always check back and have a look at it. Next week, we'll have a new computing video to show you how to make your own sprites. Okay, right, see you later, guys, and have a good evening. Bye-bye.